to go? All right, rational equations part 2. So sometimes, I like to use a table to organize my data, and then there's some formulas that you're probably going to have to know and that aren't on your formula sheet, but I think you should know them from science. Once you have the value of x, it's important that you check against the NPVs, just like that's a part of it. That's a part of 6.4 part 1. But again, we're still dealing with equations, so we're solving, right? We're still solving for a variable. I was going to say x, but it's not always x. So okay, that pink pen isn't the best. Let me grab this one. Okay. And are your answers reasonable to the context of the situation? We've talked lots about that in chapter 4, like getting a negative distance, right? So we know that we're gonna reject them if they don't make sense to the situation. Doesn't mean that you did your math wrong, just means that these are not working. Okay, so a train is scheduled to run a 160-kilometer return trip between two cities in Manitoba. If the average speed is decreased by 16 kilometers an hour, the trip will take half an hour longer. Determine the average speed of the train. Got it? Doesn't seem like a lot of numbers, right? And this goes back to kind of the max-min problems. We didn't have a lot of numbers in them. There's not a lot to work with, but there's lots of, in this case, there is lots of stuff. The first thing that you need to know is the formula for velocity or speed. Do you guys remember the formula for velocity? How fast do you go on the highway? What is the speed limit? I won't ask how fast you go, but what is the speed limit between Thompson, Manitoba and Winnipeg, Manitoba on Highway 6? 100 what? Kilometers per hour. So right there you just did the formula for speed. Speed is distance over time. Kilometers per hour, right? So we're going to call it speed. We're not going to call it velocity because we're not going to do any directional velocity. We're just going to do speed like we're driving in our car. So if you've taken a physics course, you're probably required to do velocity traveling in different directions. But we're just going to pretend we're driving cars today. So we know a couple of things. We know that each distance is 160, right? There it's 160, and home it's 160. Make sense? That hasn't changed. The two cities haven't moved. If the average speed is decreased by 16 kilometers per hour, do we know the average speed? No. So what are we going to call it? How about we use some variables that make sounding sense? So I'm going to use the letter S. Is everybody okay with that? Oh, that's in the time column. Sorry. Time is here and speed is here. So this would be S. And then we're decreasing. So the slower speed is decreased by 16. So what is that going to be? What expression am I going to write here? So we're decreasing the speed by 16. So it's going to be S subtract 16. I'm not going to use my units of measure until the end because then there'll be more letters in there that I really don't need. So now let's talk about time. When I'm traveling at average speed, do I know how long it takes to do the trip? The answer is no, I do not. So what am I going to call that one? T. Look at you guys, so smart. All right. Now it says the trip will take half an hour longer when I'm traveling at the slower speed. So what expression am I going to put in here? Plus 30. What are my units of measure for this? Hours. So am I adding 30 hours onto it? How many hours am I adding? Half an hour, so 0.5, right? So that's kind of a tricky thing too, is that we have to pay attention to units of measure. Right? So if you get something like 45, the math behind that would be 45 minutes, I'm going to take 45 divided by 60, right? Like, so that's the math behind getting that half an hour. So just keep that in mind. That's a pretty common thing that students get. I'll give it to you in minutes, and really I want things in hours because that's what speed is measured in. Usually it's measured in kilometers per hour, usually. Not always. Like gravity is measured in meters per second, right? So depending on what we're doing. But normally, and it gave us our units here, so that was an indication. Okay, so now I got this beautiful table. So I'm going to create an equation with this stuff, and I'm going to create a second equation with that stuff. So I'm going to this formula here. So speed, and the letter I'm using for speed is S. So for equation number 1, I'm going to have S is equal to distance, which is 160, divided by the time, and in this case it's just T for this one. That's nice and easy, eh, everybody? Nice and easy. Okay, equation number 2 is going to look a little bit different. Speed is now reduced by 16, so I'm going to use this one. S minus 16 equals 160 divided by T plus 0.5. All right, so this is a system. You guys learned how to do systems in grade 10. We also did systems in max-min problems, which were in chapter 3. This equation is already equal to a single variable. So S has a value of this. So what I can do is I can take that and I can substitute it in where I see the letter S. And if you just did your most recent problem set, there was a question like this on it as well. What are you doing? Are you trying to close it? Okay. Well, you got to make a commitment. You got to stand up because there's 2 things you got to do. I think you got to do the silver cord first. Silver cord first to get them straight. Are they straight? Perfect. And now you're going to use the white cord. One side of the white cord. Pull one side of the white cord. Good job. Good job. Okay, now the question is, do you want them fully closed? These are big life choices. So then you'd go back to the silver cord and then you'd flip it if you wanted that. I love it. They threw you under the bus. You were it. Okay, so now looking at this is simply a 6.4 part 1, right? So what do we do here? We're going to solve for the letter T. So step 1, factor everything. Step 2, well, it's factored, so that's why I'm pumping on to step 2. Step 2 is NPVs. So my NPVs are T cannot equal, what's the first one? 0. And T cannot equal negative 0.5. Now that one is kind of out of the scope. Out of domain. And all I mean by that is it doesn't make sense. Because what does the letter T represent? Time. So can I have a negative time? I guess maybe we could if we went back into yesterday, but the train's not going to go back into time. So when I say it's out of the domain, that just means it's not a value that makes much sense. But I'm still going to leave it there because it's good to practice that. What's step 3? Going to do our LCD. What's the LCD, or what's the denominator on the 16? 1. Does it help you to write that in? Maybe, maybe not. Just a reminder. So the LCD for this one is going to be T times T plus 0.5. Because remember that this is a set. You can't break it apart. It's not like the T's repeat, because this is a single T by itself, and this is a T with something attached to it. So those are two different things. Okay, so step 4, for equations, I time tops only by the entire LCD. So t times t plus 0.5, t 0.5, and t. Okay, now we are going to cancel any denominators that we have. So t will cancel out t. t.5 will cancel out t.5, and the 1 doesn't cancel out anything. So now I'm left with t plus 0.5 times 160 minus 16 times t, oh, I'm going to run out of room, times t plus 0.5. I'm going to have to drop my equals down here, sorry. 160 times t. Okay, so I got to leapfrog this backwards into those two. So I'm going to have 160t plus 80 minus, I'm going to put this in brackets. I'm just going to put this stuff in brackets so I can do that really quick. So I'm going to multiply these two first. So 16t, and then I'm taking these two and I'm leapfrogging it into that binomial. So I'm going to have 16t squared plus 8t. Now notice they're still in brackets, that subtraction sign is there, and I'm going to be left with 160t. Okay, so now I'm going to distribute that through the brackets. So I have 160t plus 80 minus 16t squared minus 8t equals 160t. Okay, what do you guys want to do? I got a t squared. So what do I want to do? Basic algebra or factoring? Factoring because it's a t squared, right? It's a quadratic. So I'm going to bring everything to the right-hand side because on this side it is, well, it's negative. So I'm going to bring it to the other side. So I've got 0 equals 16t squared minus 160t minus 80, minus 8t. I did something bad. I did what I told you guys never to do. That's an add sign, by the way. I didn't combine like terms, and I did it because I saw something. So this one and this one, what happens to them? They cancel each other out, right? One's a positive, one's a negative, so those are 0. So I'm left with 16t squared minus 8t minus 80. Any suggestions?
Wouldn't 8t be positive?
Nope, because we're distributing. Oh, would it? Oh, it would be. Yep, you are 100% correct. I moved it. I distributed it and then I moved it. So what do you want me to do here? I'm going to common factor out that 8, right? Like an 8 can come out of everything. So 0 equals 8 bracket 2t squared plus t minus 10. Okay, I have run out of room. Do you guys have room? No, of course not. Okay, so let's factor that. I've got the 0 equals 8, 2t squared plus t minus 10. Okay, so for this one, I'm looking at the 2 times oh, you guys can't even see that. 2 times negative 10. What do I got there? Negative 20, and my factors will be 5 and negative 4. You guys are getting really good at this. 8. So I got 2t squared. I'm going to do the minus 4t because I know I can common factor. Plus 5t minus 10. So looking at those two. And if you're doing this on a scrap piece of paper, you can simply just lose that and do the factoring. 2t, and then t minus 2. And then out of those two, I'm going to take a 5. So I'm going to get t minus 2. So I'm going to have 0 equals 8 plus 5 and t minus 2. Whew. All right, that's good. That's exciting. All right, so we're going to solve now. All right, so we're going to solve now. And I'm just going to scooch all this up here just because I'm running out of room. So I have 0 equals 8 times 2t plus 5 and t minus 2. So I'm going to have, remember that it has to be, the variables have to be included. So I'm going to have 2t plus 5 equals 0 and t minus 2 equals 0. So t is going to be equal to a negative 5 over 2, and t is going to be equal to a positive 2. Okay. So first thing I want to do is, what do I want to check? I got to check against my MPVs. So my MPVs were 0 and negative 0.5. So that's good. But what did I also want to check against? If it's reasonable, right? T represents time. So is a negative time reasonable? So what are we going to do? We're going to reject that one. Okay, so T is 2. But that's not what the question asked us. The question asked us, what was the average speed of the train? Now, if you go back up to your table, the average speed was represented by the letter S. And we can find the average speed by using the equation for average speed that we had. So we're going to go here. Now we know what T is. So average speed is equal to 160 divided by the time of 2. So the speed is 80, and what are the units on speed? Kilometers per hour. Okay. So that's good. Everybody good? Am I rushing? Did you guys get it all copied down? Good? Okay, so you can see how this is a lot more complicated. Like, it's hard enough we're like doing all of 6.4 part 1 inside of 6.4 part 2. All right, new one. My family's driving to my cottage, and I've given you the speed. They return home on the same highway. So I have a cottage and I have home. Okay? They return on the same highway at a speed of 60 kilometers per hour. Maybe they're traveling at night, maybe it's a snowstorm, but for some reason my family has reduced their speed. The trip took 2 hours, so the round trip, so that's like there and back, right? How far does the Scallion family live away from their cabin? Okay. Is it okay that we use a table? Does that make sense to you guys? And what will we be using? We're going to be using a speed formula because that's the information we have. We have distance, time, and speed. So we're going to automatically go to a speed formula. So I'm going to create a table. So I'm going to have to the cabin and from the cabin. So I'm going to have speed, distance, time. I'm just too lazy to write out the actual words. No, I'm not lazy. I'm efficient. I'm a mathematician. Okay, so let's fill in what we know. How fast am I going to the cabin? Says in the question. 90 kilometers an hour. So I'm just going to write 90. I'm going to leave the units of measure off. How fast am I traveling from the cabin home? 60. Okay, that's good. Do we know the distance to my cabin? No. Okay, so we're going to call it D. Seems reasonable for distance, right? Now, what will the distance change from my house to my cabin? From my cabin to my home? No, nobody's picked up my cabin and relocated it, right? So if this one's D, we know that this should be the same distance. Does that make sense to everybody? Because those are fixed places. They're not going to move. Okay, now here's the trick with this question. The round trip took 2 hours. So there and back took 2. So we kind of have to pull it apart. Do we know how fast it took us to get to the cabin? Just the get there. No, we don't, right? So what are we going to call it? T for time. Beautiful. Now, if this took me 45 minutes to get to the cabin, how would I calculate what's left? I'd minus that from 2 hours, right? Does that make sense to everybody? So it'd take me 1 hour and 15 to get home. But we don't know how long it took me, but really, you just got to do the math. Because it's the 2 hours minus whatever it took me to get there, right? Everybody agree with that? Okay, so what's step 1 of this? Well, I don't know what step we're on, like -2 at this point. We got to create equations. So equation number 1 here, and equation number 2 with this information. And guys, I'm going to tell you that every scenario will be different. Every scenario will be, like, you're going to have to really think about it when you're putting this together. Because although we use the same sort of style, based on the information given, you're going to have to create the equations in a different way. Okay, so equation number 1. Equation number 1. So that is to the cabin. So again, we're using the speed equals distance over time. This is nowhere on your formula sheet, ladies and gentlemen. Okay, so get a tattoo. Remember that speed is measured in kilometers an hour, so kilometers on top, time on bottom. So we're going to have 90 equals distance over time. That's exciting. Not really much in that equation. So equation number 2 is 60 equals D over 2 minus T. All right. So now the last question, it was really nice because it equaled a single variable. This one does not. This one does not equal a single variable. But I can rearrange equation 1 So that's what we're going to do now. So the easiest one to rearrange for is D. So how do I get rid of the T on the bottom? Times by T. So if I times this side by T, I times that side by T, those T's will cancel each other out. So D is equal to 90T. That's exciting. So once I have that information, I can take that and substitute it in there. So now we're into our solving equation. So it's going to be 60 equals 90T over 2 minus T. What is the denominator on 60? 1, right? Okay, so let's do NPVs. Oh, factor everything, but it's kind of already factored. So I jumped to NPVs. T cannot equal +2, right? So it would be positive 2, but if you want to see the math for that, 2 minus t equals 0. I'm going to add t to both sides. So t is equal to 2. It's kind of hard when they're not in the right order. Like, it's not always easy to see. What's the LCD? 2 minus t. Easy peasy, right? So that means we're going to take the LCD and we're going to times tops only by all the terms. And then we're going to cancel out stuff. So that's nice. This side, nothing gets canceled. So it's going to be 60 times 2 minus t equals 90t. So we're going to have 120 minus 60t equals 90t. So basic algebra or factoring? Algebra, right? Because there's no t squared, right? That's why we're making those decisions. So I'm going to bring all my t's to one side. So I'm going to have 120 equals 150t. Divide by the coefficient. T is equal to 4 over 5. 4 over 5 what? Oh, 4 over 5 what? Hours, right? So really, if we converted that to a decimal, decimals might be happier for you here. So 0.8 of an hour. So I got to check that against my NPV. What's my NPV? 2, so we're good. That works. That's a good answer. But the question asks, how far away do I live from the cabin? And right now you just found the time that it takes me to get to the cabin. So again, I'd go back to that original equation. And FYI, it will work in both equations. The reason why I keep picking equation 1 is because it's the simplest out of them all. Does that make sense to everybody? Okay. So I'm going to take this and I'm going to substitute it into 90 equals d over t. We know our t is 0.8, so that's going to go in there. So 90 d over 0.8. And how do I get rid of that? Times both sides. I feel like we've done this already today. I remembered to charge my calculator. I lost my pen top. So I'm going to have 90 times 0.8 equals d. So we're going to have 72 equals d. What's my unit of measure on that? Kilometers, right? Because it's just the distance this time. Okay, I'm never going to find my pen top. So that is kilometers. It's at the front of my desk. It's with this floor, you can't find anything on it. All right, there we go. Okay, easy peasy, right? So my last example, I think, is my worst. Oh, I don't enjoy this. Okay, this is my least favorite one because it's the most confusing. Maybe I should use an erasable pen if I screw it up. I'm going to use an erasable pen. All right. So Stella takes, so now we're not doing distance and time. I like distance and time. It makes me feel good. This is like a fraction one. Okay. So we have Stella and we have Jose. My great uncle name was Jose, just so you know. Just so you know. Okay. Job alone. After 1 hour. Oh, let me try that again. This is why I used erase pen. After 1 hour, I said it and then I didn't write it correctly. Okay, so how long does it take Stella to do the job alone? Do you need a minute to copy down the chart? I'll draw on the bottom line. You guys take a minute to copy that down. Okay, how long does it take Stella to do the room by herself? It's in the question. 4 hours. So if Stella is painting this classroom, it's going to take her 4 hours to do if she's alone. Okay, how long does it take Jose to do the room if he was alone? 3. Okay, so after 1 hour, how much of the job has Stella completed? 1/4. Okay, I like it. All right. And Jose, after 1 hour, 1/3, right? Does that make sense? Like if we checked on him in an hour, he'd be 1/3 of the way through painting this classroom. Okay, after T hours, so we don't know how many hours. So essentially all we're going to do here is we're going to say after an unknown amount of hours, it's just going to be a fraction, right? So we know that if I check on them after 2 hours, it would be 2/4. If I checked over at 3 hours, it would be 3/4. If I checked at 3.5 hours, it'd be 3.5/4. Make sense? We just don't know what the T is right now. And then that would be the same for Jose. Make sense? So that kind of makes sense. I don't know if you guys would intuitively get this one. All right? Everybody with me here? So what we know is that these two have to equal 1 job, right? 1 job. So 1 job, 1 complete job. Because we want to know how long it takes them to paint if they work together. So we know that Stella plus Jose is going to equal 1 job. And that's going to be T/T. Because it's going to equal 1, right? I think I did this right. Maybe I should stop and check and just make sure I did this right before I continue you guys down a path. I'm positive this is right, but I could be wrong. This is the one I like the least. Oh, you've made the decision? You've made the decision? Okay. All right. Maybe it might be better if we write this as 1 job. Maybe that'll be better. Everybody good with that? If we write that as 1, and I'm going to just write a note for 1 complete job. Okay, NPVs? There's none, because there's no factors on the bottom, right? There's no factors on the bottom. So what's my LCD? 12. This is a nice easy one. Table was hard to put together, but it's a nice easy one to do. So we're going to take 12 and we're going to times all the terms by 12. So 4 goes into 12 3 times, so I'm left with 3t here. And 3 goes into 12 4 times, so I've got 4t here. And that's going to equal 12. So I have 7t equals 12. Divide by 7, divide by 7. T is equal, to 12 sevenths. And what is our units of measure here? Time. Hours, okay. Would it make sense for you to switch it to a decimal? Would that make more sense to you guys? So T equals 1.714 hours. I don't know why I picked 3 decimal places, but that's what I went with. So you guys know that it's not 1 hour and 70 minutes, because that doesn't make sense. You know that if I asked you for hours and minutes, you'd say, okay, well, it's 1 full hour, and then we'd take the decimal that's left, so 0.714, and we'd times it by 60 to get how many minutes there are there. Just sometimes that conversion, like I'm just so used to that makes sense to me that I don't really share that piece. This 1 times 60, so that would be 42.86. So we would have 1 hour, and we'll round it to 43 minutes. And that makes sense. The idea is that that it would be much faster if 2 people were doing the job. Does that make sense? Like, so if you got an answer of 12, that's not going to work. Or you got an answer of, 17 hours or something, that also shouldn't make sense to you guys. And there was no MPV, so we didn't have to check it. Yep. That's fine. Yep, that's a perfectly good answer. But I just want it, like, sometimes I might ask the question, like, how many hours and minutes? Just so you know how to convert. Okay, toughest lesson in grade 11 pre-cal. Done.